Hi everyone. So up until this point, we have been working with polynomials in the form ax squared plus bx plus c, and we have done a equals 1. Okay, so going forward today, we're going to start looking at difference of squares where b equals 0. A doesn't necessarily equal 1 in the examples we're going to look at, but B is going to equal 0. So let's have a look at that. We're under class notes, lesson 5 here, difference of squares. So let's do an example to begin with. Okay, so let's say if we had x squared plus 0x minus 16. Well, using what we already know, we want the back part to be a product of two numbers. So what would be a product of two numbers? That gives me a sum of 0. So product here and then sum here. Well, I can have 4 times 4 would give me 16. But in order to have a sum that is 0, I would need a positive 4 and a minus 4. Okay, so that means my factored form then would be x plus 4, x minus 4. So this is all based on what we have already learned. And this is essentially exactly what the difference of square is. So if I were to rewrite this part right here, if I were to rewrite it in the form a squared minus b squared, it would be x squared minus, because I don't need this part inside, minus 16. Or in the square form, it's x squared minus 4 squared. So I'm going to rewrite this formula here and just color code that for us. So we have A, and our B on the back end here, B. This is our B right here and our B in the back. X is our A in the formula and X is right here. So that's what we're doing, something pretty simple, but let's have a look at some ways it works. So how can we actually envision what this difference of squares looks like, and why do we call it a difference of squares? Well, for one, anytime we have a 2 exponent, it's squared. In terms of area, it looks exactly like one side multiplied by another. So let's say a squared is the first thing we have here, a squared. Okay, then I have a length of a over here and I have a length of b on the other side. The second part we have is b squared. So just imagine it's the area of a minus the area of b. So my b here is somewhere inside, and the measurements for this are b by b. So what am I left with? The area that we are actually trying to calculate, so whatever is after this equal sign here, this is the area, and this part is what we call the difference of squares. Difference of squares. And what squares are we looking for? Well, in this particular case, is the difference of a squared minus b squared. So what does a squared minus b squared equal to? Well, if we were to rearrange our blocks, then what we get is, so I'm going to take a part of this, what we get is a length of a. Okay, so I know I have some kind of a here. Okay, so this length right here, a. And I have this block right here. This side is also a. What I have here on top, this is a minus b, right? So I have a minus b right here. On the bottom right here, I also have a minus b, a minus b. So that's the first part of my area. And the second part that I have left here is I'm just going to separate them. A smaller chunk. This section right here then would be B. So I have B over here. And this part right here is, again, A minus B. So I have A minus B right here. So that is my new area. So let's multiply our new areas together. I have in my first shape right here, I would have A times A minus B. My second shape here, I have B times A minus B. I add these two together, and what do I get? I get A times A minus B plus B times A minus B equals A plus B times A minus B. There we go. One side of my equation, A minus B plus A plus B times A minus B, and the other side here, A squared minus B squared. And that goes back to exactly our difference of square formula. Okay, so that's the way we kind of envision it and reorganize our equation. Now, let's do an actual example and just verify it so we kind of go backwards. So in classroom example, let's just do number 1 over here, 1a, a squared minus 4. Very simple. Right away, you see that it is actually the same as a squared minus 2 squared. So we have a minus 2, a plus 2. Now let's go backwards just to verify, okay? I want to verify with you guys now and then just to make sure we are actually doing the right thing. So I have a times a is a squared plus 2a, and minus a times a, we have minus 2a, and minus 2 times positive 2, we have minus 4. So then we cross out what we have in the middle here. We are left with a squared minus 4. It works! All right, so we can try a couple more examples. You can do the other ones yourself. Equals t minus 12 and t plus 12. For most of these, I think you guys would be able to find the factored form just using mental math. Okay, and our a and b, or our first term and our second term, they can be variables. They can be in any form. Right here, we have 7 already being squared, so we have p minus 7 and p plus 7. Oops, sorry, 7 over here. Okay, now looking at this verification we just did here, the reason we're able to get 0, b equals 0, so b in our formula of a squared plus ax squared plus bx plus c, we can get b equals 0 because these two actually cancel out. And the important thing is that our signs need to be different. Our signs are different because our second term has a minus in the front, okay? As in c here has to be a negative number. So if we had a positive number, this wouldn't work at all. So let's try an example here. In our classroom example, let's keep this organized. I'm going to scroll down here. In our classroom example number 2, E gives you 4x squared plus 25. Don't make the mistake of trying to do something like 2x plus 5 and 2x plus 5. Okay, this doesn't work. And how do we know that? Well, let's go backwards and try to verify that. We have 4x squared plus 10x plus another 10x plus 25, and then what we get is 4x squared plus 20x plus 25. This doesn't work, okay? So don't make that mistake. All right, so A couple other examples that we can look at involves using other variables in our difference of squares. For example, if we had 9m squared minus 4n, you simply look at the first term all squared. So let's break that down here. We can see it as 3 squared times m squared minus 2 squared times n squared. Or if I rewrite that, remembering our law of exponents, I can take the 2 on top here out in both cases, okay? So I have 3m squared minus 2n squared. I look at the inside here as one term, and I look at the inside here as another whole term. Then what I get is 3m minus 2n and 3m plus 2n. 3m is our a in the formula and 2n is our b in the formula. Remember the formula was a squared minus b squared equals a minus b, a plus b. Okay? So quick and simple here. I'm going to jump to example number 3 here. For question 3, we're given a squash court that is rectangular and has an area of, so this is example number 3, an area of 25a squared minus b squared. I'm going to leave this question for you guys to try it out as a challenge. But if you were to write the expression for the length and the width of the floor, we don't know which one is which, but we do know that the two sides are the square of these, okay? So then we have 5a minus b, 5a plus b, minus b here, 5a plus b. The drawings of this with the dimensions, they're not accurate, okay? But I want you guys to try out part B here and see if you can figure out the length of the width and the width of the floor. 2. And what we're left with is a squared minus 25, and that's something we can square. So we have a minus 5 and a plus 5. For b here, 3x squared minus 12y squared. The first thing we can factor out is 3, and we're left with y squared minus 4y squared. 3x minus 2y, x minus plus 2y here. As for C here, the first thing when we look at 144p squared q squared minus 4, okay, so what factors do we actually want to take out? Of course, you can go ahead and see that, well, this could be 12 squared and this could be 2 squared. So maybe I can just go like 12pq minus 2 and 12pq plus 2. Okay? Sure, you could do that, but you can see right away, well, I could probably factor something out here and I could factor something out here. So let's go back to our first step. What could I do instead to actually make my factoring a little bit shorter? Well, let's factor out 4. If I were to factor out 4, then what I'm left with is 36p squared q squared minus 1. And then what we're left with is 6pq minus 1 times 6pq plus 1 to form our difference of squares. Okay, for D we have 3x cubed minus 27x. So the first thing we can factor out is 3x, which is a common factor in both of them, and we're left with x cubed minus 9, and then we have 3x still in the front, where we have here x minus 3 times x plus 3. Okay, So for your homework, I will post the exact questions for your homework. I know that some of you guys might be away or don't have your workbook handy, so I'll actually post the pictures of your workbook so that you can have the questions readily available. I would like for you to try to post your homework daily once it is finished. So for example, I could go to our notebook here. You'll be able to only see your own once again. So if I were to go to Bernice, I'm going to push this homework to you guys first. So class notebook, I'm going to distribute it to you guys. Okay, I'm just going to wait for that to load here. If I were to go to your homework right now, you only see lesson 4 because I haven't asked for your lesson 5 yet. Now if I were to go to lesson 5, my homework page here, homework, and I go distribute, then all of you guys will have it under your homework pages, and what you can do is just add your homework underneath here, okay? So again, make sure you have your pages, like take a picture of it, and then I'll kind of go through your homework on a more regular basis than we did in class, okay? Send me a message if you have any questions. I'll have the PDF of your workbook pictures posted on your class pages if you need access to that.